Hello.
Hello.
Yeah. So last class we were looking at some inequalities problems, right?
Yeah.
So the first one that you had to try was this one. Let A, B, C, D be real numbers, not all equal. You have to prove that at least one of the numbers A minus B square, B minus C square, C minus D square, and D minus A square is less than 1 by 4.
Yeah.
Okay, so did you try it?
Yes.
Tell me what you have attempted.
So if you assume none
Hmm.
none of a minus b squared, b minus c squared, c minus d squared, and d minus a squared are less than 4,
None
that
of them
pretty
is
much,
less than 4. Basically, that means all of them are greater than equal to 1 by 4.
yes.
So then,
So then you have that they're all greater and equal to 1 by 4. What you can do is you can add all of those inequalities,
hmm,
and then you get that um
A plus B plus C plus D minus A square minus B square minus C square minus D square is greater
yeah,
than equal to 1.
yes. And
Now,
then since you have um let me just see.
then you should bring
Yeah.
everything to one side.
Yeah. Oh,
Take all this and bring it to one side, right?
yes.
You will get A square plus B square plus C square plus D square minus A minus B minus C minus D plus 1 is less than equal to 0, right?
Yes. And
Now,
then what you can do is if you split the one into four
hmm,
quarters,
hmm.
then what you can do is you can complete the square with
So we can write all of them as A minus half whole square
yes,
plus B minus half whole square plus C minus half whole square plus D minus half whole square is less than equal to 0, but this is impossible, right?
yeah,
The only
because
way it is possible is if all of them are equal to half, right?
yes,
But the question said that they are not all equal.
yeah,
So then this is impossible and this is a contradiction now, right?
yes,
So our initial assumption is incorrect, right?
yes, yes,
Which means that at least one of them must be less than 1 by 4.
yes.
That is the proof for this one. Then the second question was about triples, right?
Oh yeah,
The second question was find all triples xyz so that you have 2x square plus 3y square plus 6z square is equal to 2 times x plus y plus z minus 1, right?
yeah.
Okay, so did you try this one?
I tried it, but
Mm.
I wasn't exactly sure how
Mm.
like the answer would be. Like I wasn't sure if I actually had to find
It
every
is
single.
similar to the previous one. Like the previous one was solved because you were able to write it as perfect squares, right?
Yeah,
It's not like there is any way in which you can solve one equation with three unknowns, right?
yeah,
Here x, y, z are all real numbers, so it's not like they are integers or something, no?
no,
So the only way it will work is if some trick happens with squares.
yeah,
Otherwise, it's impossible to solve three variables, right?
yeah,
So what I will do is I will bring everything to one side and hope for some nice trick.
Yeah.
3y square minus 2y plus 6z square minus 2z plus 1 equals 0, right?
Yeah.
So what I can do is here I can take 2 common and I have x square minus x, and then I have a 3 common and I have y square minus 2y by 3, and then I have a 6 common and I have z square minus 2z by 3 plus 1,
Yeah.
right?
Yeah.
Equals 0. So the only thing I can think of is of completing the square here and here, right?
Okay. Yeah.
So let's try that. So here, in order to complete the square, I need a plus 1 by 4, right?
Yeah.
I can write it like this, plus 1 by 4, and then minus 1 by 4, which gets multiplied and becomes a minus half, right?
Yeah.
Do you understand?
Yes.
Then here, y square minus 2y by 3, 1 by 3. So I need to add a plus 1 by 9 minus 1 by 9, right?
Yeah.
So minus 1 by 9 can come out and become a minus 1 by 3, right?
Yeah.
Then plus 6, z square minus 2z by 3 plus 1 by 9. I need a minus 1 by 9 and minus 1 by 9 into 6, right?
Yeah.
Wait 1 second. It is not 2z by 3, it is 2z by 6, right?
Oh, yeah.
It is 2z by 6. So technically, I have to write like this. So 2z by 6. So I need to add a plus 1 by 6 square, right?
Yeah.
Plus 1 by 36. Minus 1 by 36 multiplies with this becomes a minus 1 by 6, right?
Yes.
Plus 1 is 0. Now see what is happening. 1 by 2 and 1 by 3 and 1 by 6 adds up to what?
-1.
That cancels.
Yes.
What are you left with? 2 times x minus half whole square plus 3 times y minus 1 by 3 whole square plus 6 times z minus 1 by 6 whole square.
Yeah.
See, the only reason this is doable now is because it is sum of squares equals 0.
Oh, yeah.
If it was anything else, if it was equal to 1, if the 1 didn't get cancelled, right,
Yeah.
then there is no chance of solving. Do you understand?
Yes.
Sum of squares equals 0, therefore each of the squares must be 0.
Yeah.
And therefore you get x is half, y is 1/3, and z is 1/6.
Yeah. I actually ended up finding that, but it wasn't the correct way.
But how did you find that?
Uh, I think
You can
I,
guess the answer maybe, but you can guess the answer but you need to show it also, no?
yeah,
Even if you guess the answer, you'll have to show why and why not others, right?
yeah,
Guessing the answer is good, but then you have to prove that why no other answers are allowed.
yeah,
So the way to do the proof is this only. You have three equations in one three variables in one equation. You have to do some trick like completing the squares.
yeah.
Okay. The next question was which one?
Uh, it says solve in real numbers the equation the
Hmm.
square root of x plus square root of y plus 2 squared of z minus 2 plus the square root of v plus the square root of t equals x plus y plus z plus v plus t.
Right. So this is the situation. Right. So first thing that you should notice is always that uh, when you have square roots and all, and you have to do real numbers, then all of these have to be positive, right?
Yes,
What we know is x is y, v, and t are greater than equal to 0, whereas z is greater than equal to 2.
yeah,
that is known already. Otherwise, the equation will not be defined, right?
Yeah.
Now, again, it's the same trick. Basically, you have root x and you have x, no? I will complete the square.
Oh, okay.
So what I will do is, I will bring it to one side. So let's do x minus root x. Similarly, you have y minus root y. You have v minus root v. You have t minus root t. All those are similar to each other, right? See?
Yes.
Then the only one that is slightly different is z minus 2 times root over z minus 2, right?
Yeah.
So I have brought everything to one side. These ones will be done if I have a plus 1 by 4 minus 1 by 4, right?
Yes.
If I had a plus 1 by 4 and minus 1 by 4, then this will become a perfect square, right?
Yes.
So I can write it as root x minus half whole square minus 1 by 4 plus root y minus half whole square minus 1 by 4 plus root v minus half whole square minus 1 by 4 plus root t minus half whole square minus 1 by 4, right?
Yeah.
Notice here, I need a z minus 2 and stuff, no?
Yeah.
This part is under the root, so the square of that will be z minus 2, right?
Oh, yes.
So I should write it like this, z minus 2 minus 2 times root over z minus 2, and then I need a plus 1, right?
Yes.
Plus 1 for the third term, right?
Yes.
So I have to do minus 1 for this, and I have to do a plus 2 for the minus 2 that I have made up, right?
Yes.
Do you understand?
Yes.
So now notice that these three become a perfect square, but what is left here? Plus 1.
Yeah.
And what happens to that plus 1? It gets cancelled with these four.
Yeah.
And I'm getting a perfect square here. The perfect square here is root over z minus 2 minus 1 whole square, right?
Yes.
So now you have the sum of 5 perfect squares.
Yeah.
It is equal to 0. So all the
Yeah.
values are going to be simple. Root x is equal to root y is equal to root v is equal to root t is equal to half, right? So
Yeah.
x, y, v, t are all equal to 1/4. And root of z minus 2 is equal to 1. So z minus 2 is 1. So z is equal to 3.
Yeah.
Do you understand?
Yeah.
Okay. The next problem is another equation, I think, right? Yeah. Next
Yeah.
problem was solve in real numbers this equation. Yeah.
Yeah.
Solve in reals. The equation was root over x1 minus 1 square plus 2 times root over x2 minus 2 square plus so on. The pattern keeps going on n times root over xn minus n square is equal to half of x1 plus x2 till xn. Correct?
Yeah.
Notice that this equation has actually got n variables,
Yeah.
but only one equation and n variables. So again, what we expect is some perfect square stuff to happen, right?
Yeah.
You have seen now already in 3 questions, that is what helped us solve it, no?
Yeah.
So we will try that only. It's just that first we will notice that all the roots have to be real. So you knew already that x1 is greater than equal to 1 square, x2 is greater than equal to 2 square, and similarly xn is greater than equal to n square,
Yeah.
right?
Yes.
This is for the left hand side of the equation to be defined, correct?
Yeah. Yes.
So now what can we do? We can multiply the 2 everywhere, right? So
Yes.
So it will become 2 times this x1 minus 1 square plus 4 times root over x2 minus 2 square and so on plus 2n times root over xn minus n square is equal to x1 plus x2 plus xn,
Yeah.
right? And
Yeah.
then let's bring the terms to one side. Let's look at each fraction, each type of term together. x1 minus 2 times root over x1 minus 1 square, right?
Yeah.
In order to convert this as a perfect square, I can't do much with this, so I need that term to appear here, no?
Yeah.
So I need x1 minus 1 square to appear here, right?
Yes.
So I need to add plus 1 square there somehow. Do you understand what I have done?
Yes.
And this term are fitting now. I just need the third term, which will be plus 1. So I have to go to minus 1 also,
Yeah.
right? Notice
Yes.
that this plus 1 will cancel this minus 1.
Yes.
So what will happen is this thing, this term, and this term together becomes what? Root
Yeah.
over x1 minus 1 square minus 1 whole square.
Yes.
Do you understand what I'm saying?
Yes.
Similarly, you can do everyone, correct?
Well, wouldn't you need different?
See what happens. Second one, let's see what happens. x2 minus 4 times root over x2 minus 2 square, right?
Yeah.
What do I need here? I need to
Uh,
do x2 minus 4, no?
yes.
So what do I need? x2 minus 4. I need to do a plus 4, right?
Yeah.
Minus 4 times root over x2 minus 4. But now I
Oh,
need the third term, right?
yes.
Third term will be what? 2 square.
Oh,
So I have to do a plus 4 and a minus 4 again, right?
yes.
Can you see that this plus 4 gets cancelled here and you are left with what?
Just root of x
x2
squared.
minus 2 square minus 2 whole square.
Yeah, I see.
So it will all work out nicely and you will be able to write it as sum of so many perfect squares equal to 0, and after that you can find each of the variables.
Yeah.
Is it clear?
Yes.
So it's the same trick. Basically all the questions so far are the same idea.
Yeah.
Next problem was which one? Find all triples, that one, right?
Yes.
Find all triples ABC of reals real numbers greater than 1 such that a into root over b minus 1 plus b into root over c minus 1 plus c into root over a minus 1 is equal to ab plus bc plus ca by 2. Okay, so what have you tried here?
Uh, well, at first I tried to square it, but that didn't work. So then I
Hmm.
tried to, I think I mul a multiply.
So try it right now. If you have not gotten it, try it right now. You should be able to get it now.
Okay.
Given what we have discussed so far, the questions we have done so far, you should be able to do this one also.
Okay. b over 2. A over b minus 1. And this will be a over b minus 1. And this must be weird. Must be a over 2. Then we times and then you do minus b over 2 plus 1 that will equal to 2 b minus 1 plus 2 squared minus b over 2 plus 1. Then b minus 1 squared is this one. Plus root of c minus 1 times 0 2 all squared equal a minus 1 minus z a continues with 0 2 minus a 2 plus 1 equal to 0, and then it's root b minus 1 minus a over 2 squared plus root c minus 1 is b over 2 squared plus root a minus 1 minus c over 2 squared plus 1 is equal to a plus b plus c over 2. I triples real number system. Do that for 3.
First step would be to multiply by 2 and bring it all on one side.
Yeah.
So you can say AB minus 2A root over B minus 1 plus BC minus 2B root over C minus 1 plus CA minus 2C root over A minus 1 equals 0, right?
Oh, yes.
What should we do now here?
Complete the square.
But you can't do it without taking something common, no?
Oh, yeah.
You
So
should
you
take A common.
yes.
B minus 2 times root over B minus 1, right?
Yeah.
This is obvious now, completing the square here.
Yes.
What should I do? Tell me.
Well, you need minus 1 for the b.
So I'll put a plus 1.
And then you need a
Plus
plus
1.
1.
So
Yeah.
put a minus 1 again, right?
Yes.
This plus 1 and this minus 1 can be removed, and you're left with this, this, and this, right?
Yes.
So that is clearly A into root over B minus 1 minus 1 whole square.
Yeah.
Similarly, same thing will happen here if you take B common, and here if you take C common, right?
Yes.
And since all of them are positive numbers greater than 1, so it is now going to be three positive terms being added, three terms like this being added, right?
Yeah.
So how can they be equal to 0? The only way is if each term is 0.
Yeah.
So you will get the values then. Root of b minus 1 is 1. So b minus b is 2, and a is 2, and c is 2. Do you
Yeah.
understand?
Yes.
Was there any other question?
No.
Okay. Okay. So the next problem that we look at is this one. Solve in positive real numbers the equation x square plus y square by 1 plus xy is equal to square root of 2 minus 1 by xy.
Yeah.
So try to see what you can do.
Sounds familiar. So, guess we do time for that. 3 plus 1 minus 2 minus x1 2 minus x1. X3 plus y minus x1 2 which way beside again.
One hint that I can give you is that the problem will become easier if you change the variable and think of x plus y and xy as your two variables,
Oh, okay.
because you can write the whole thing in terms of these also, right?
Yes.
Let's call this s, let's call this p. Can you rewrite the equation using s and p?
Well, you wouldn't be able to do x squared plus y squared.
You will be able to do it if you use your head a little bit. Think about it for 1 minute.
Okay.
You don't want to think, then you will not be able to do it.
2 plus 5 2 minus y x minus 2x1 1 plus x1 2 minus x1.
Are you able to write x square plus y square in terms of s and p?
Yes.
What is it?
Uh, s squared minus 2p over 1 plus p is equal to the square root of 2 minus 1 over p.
So why would you say you can't do this? It is coming, no?
Yes.
Now think about it. Think about this problem.
Okay. Yeah.
There is a clever step here. You need to realize that we can say that x plus y whole squared is always greater than equal to 4xy. Do you know this?
Oh, oh, um, 2xy.
Do you realize that it will always be greater than equal to 4xy?
No.
Think about it
Because
for a minute.
that is x squared plus 2xy plus y squared equals y. The x squared plus y squared is greater equal to 2xy. I mean, if x is greater than y, that's
What are you doing? This is an algebraic identity. You don't have to try x is greater than y, you know.
well, uh,
This is always true for whatever x and y. And it
oh,
is super obvious.
oh,
Which,
yes, I see, I see.
what do you see?
Because you can get x minus y whole squared is
If you
greater
bring
equal
it
to,
to this side, is it becoming this?
yes,
Is that obvious?
yes,
So is it true, this thing?
yes,
Now, if you think about it, you have basically x plus y whole square minus, so that can be written as s square is greater than equal to 4p, right?
yes,
Can we write s square minus 2p is greater than equal to 2p?
yes.
Why did I bring 2p here?
Because we have s squared minus 2p in the equation.
So we get this. And now, should I divide by 1 plus p?
Yes,
Why? Because I have that here, right?
yes,
So am I getting something about the left hand side here that this is greater than equal to this?
yeah,
So the benefit of that is that I know this is equal to this, right?
yes,
Can we say root over 2 minus 1 over p will be greater than equal to 2p by 1 over p?
yes,
Now I have only one variable,
yeah,
correct?
yes,
I have basically removed my variable s and I am getting a single variable inequality.
yes,
Because I saw that x minus y square is greater than 0, so x plus y whole square is greater than 4xy. So s square is greater than 4p. So s square minus 2p is greater than 2p. Dividing by 1 plus p, I'm getting this is greater than 2p by 1 over p. And that is equal to root over 2 minus 1 by p, which is greater than this.
Yes.
Solve this inequality. You should square it. You will get 2 minus 1 over p is greater than equal to 4p square by 1 plus p whole square, right?
Yes.
Now solve it. Bring it everything. You can multiply by 1 plus p square, simplify it and all.
Okay.
This is what it looks like.
Yeah. Yeah. Yes.
Bringing both of these terms to the other side. We'll take a common denominator p into 1 plus p whole square. You are getting here 4p cube. Then plus 1 plus p whole square minus 2 times p into 1 plus p whole square. Correct?
Yeah.
So then we will simplify it further. 4p cube minus p square minus 2p plus p square plus 2p plus 1. And then minus 2p minus 2p cube and minus 4p square, right?
Yes.
So we are getting 2p cube, this and this, p square minus 4p square, so minus 3p square, and 2p is getting cancelled, plus 1 divided
Yeah.
by p into p plus 1 whole square. Correct?
Oh, yes, yes, yes.
Can we factorize the top part? How do you factorize the top part? It's a cubic. What should I do?
You can uh say minus. You can try to complete the cube by
What do you mean
minusing.
complete the cube?
So you say p cubed minus 3p squared. Oh wait, and then plus 3p
It won't work. There's
minus.
another p cube left.
Yep. Um.
Do you know factor theorem?
Oh yes.
So what is an obvious factor of this cubic? What is an obvious root? Can you
Oh,
see the cubic and
one.
see an obvious root?
One.
If
What?
one is clearly a root, what is a factor?
1 minus p.
Not like that. It is p minus 1. Why are you saying 1 minus p? If 1 is a root, then p minus 1 is a factor, right?
Yeah.
So we can divide by p minus 1.
Yes. Yes.
When you divide by p minus 1, you will be left with basically p minus 1 into 2p square minus p minus 1.
Oh yes. Yeah.
Divide by p minus 1, this is what will come.
Yes.
We can factor this also actually. By middle term factor, you'll get 2p square minus 2p plus p minus 1. You'll get 2p, p minus 1 plus 1. 2p plus 1 into p minus 1, right?
Yes.
So the whole cubic is becoming p minus 1 into this So the cubic is becoming basically p minus 1 square multiplied by 2p plus 1.
Yeah.
We are getting p minus 1 square multiplied by 2p plus 1 divided by p into p plus 1 whole square is less than equal to 0.
Yeah.
Do you understand what I'm saying?
Yeah.
Now, the question had already said that these were positive real numbers x and y, right?
Yes.
So p is positive, correct?
Yes.
If p is positive, this is positive, this is positive, this is positive, this is also positive. How can it be less than 0? Right?
Yeah.
So what is happening? What can we do now?
Uh.
The only possibility is for it to be equal to 0, right?
Oh, yes.
Can't be less than 0 because p is positive. P was technically xy, and xy were positive real numbers as mentioned in the question.
Yes.
So the only possibility is that it's equal to 0, which means p should be 1.
Yes.
If p is 1, if you put that in the original equation, you will get s. The original equation was s square minus 2p by 1 plus p is equal to root over 2 minus 1 by p, right?
Yes.
So put p is equal to 1. S square minus 2 by 2 is equal to root over 2 minus 1. So 1. You're getting s square is equal to 4. S is equal to 2,
Oh,
right?
yeah. Yes.
We are ignoring the minus 2 because we said that x and y are positive.
Yes.
And s is equal to x plus y. So we are getting x plus y is equal to 2 and xy equals 1. The only
Yeah.
possibility here is x is equal to y is equal to 1.
Yeah.
If you need a proof of that, you can say y is equal to 1 by x here and put it in this equation. You'll get x plus 1 by x equals to 2. The
Yeah.
quadratic has only possible equal roots at 1.
Yes.
So the point of the question was, first look at the given equation, use x plus y and xy as new variables, then realize that s square is greater than 4p. So s square minus 2p is greater than 2p, and using that you can convert the statement of the problem into one inequality with only p left, right?
Yeah.
Earlier there was s and p, but you can remove the s and say it becomes an inequality with just p.
Yes.
If you carefully simplify, you will realize that it can only happen when p is equal to 1. And as soon as
Yes.
p is equal to 1, s is becoming 2.
Yes.
And then the question is over.
Yeah.
Do you understand what is happening?
Yes.
Okay. Then a couple of questions, and then this chapter is roughly done. Actually, one more class we'll do for this chapter, and then we'll move on to other topics.
Okay.
So next class will be about this chapter itself, and these are the questions that you need to try before next class. So first one is solve in positive reals the equations x cubed by 4 plus y squared plus 1 by z equals y cubed by 4 plus z squared plus 1 by x equals z cubed by 4 plus x squared plus 1 by y equals 2. So technically these are three equations. Everything is equal to 2. Right?
Yeah.
Okay. Next question. is one second. Prove that for any real A and B to have a square plus 1 times b square plus 1 plus 4ab is greater than equal to 2 times of ab plus 1 times a plus b. Okay.
Okay. Yeah.
Now write down these questions basically.
Yeah.
The third one is let A, B, C be real numbers. You have to prove that a square plus b square plus c square minus 2 times a plus b plus c whole square plus 1 plus ab plus bc plus ca whole square is greater than equal to 0. Write down the question.
Yeah. Uh. Okay.
Okay. Have you written
Yeah.
these three?
Yes.
Okay. Problem 4 is find all triples. Find all triples XYZ of positive integers such that 5 times x square plus 2y square plus z square is equal to 2 times 5xy minus yz plus 4zx and at least one of xyz is a prime number. Write down the question 5xy minus yz plus 4zx.
Okay.
And at least one of xyz is a prime number.
Yeah.
Then this question, I think last two questions maybe. Okay, maybe there are 2-3 more questions. So we'll say this one. Let an, where n is greater than equal to 0, be a sequence of real numbers. Sequence of real numbers such that you are given that an plus 1 is greater than equal to an square plus 1 by 5 for all n greater than equal to 0, right?
Yeah.
You have to prove that square root of a n plus 5 is greater than equal to a n minus 5 whole square for all n greater than equal to 5.
Yeah.
This question is US Maths Olympiad 2001.
Oh,
So question number 5. You need to try it. Then have you written it down? All of this?
yes.
Okay. Problem 6 is part A. Prove that if x and y are greater than equal to 1, then x plus y minus 1 by x minus 1 by y is greater than equal to 2 times root over xy minus 2 by root over xy. This is part 1. And part
Okay.
B is prove that if ABCD is greater than equal to 1 and ABCD product. So notice that this is all of them are greater than equal to 1, right? A comma
Oh,
B comma B comma C comma D, right?
yeah.
And here we have a product of ABCD is equal to 16. Then A plus B plus C plus D minus 1 by A minus 1 by B minus 1 by C minus 1 by D is greater than equal to 6. This question is Romanian Maths Olympiad 2019. Write this down and then there is one last question.
I need some time to work on. Nearly done. Oh, just A plus C plus D plus B plus C plus D minus 1 minus 1 C minus 1 D 6. Okay. I'm done.
Okay, actually that's it. These are the
Oh, okay.
questions. You need to try them out and then this chapter is done and then we'll move to other topics in algebra.
Okay.
There were some other topics that you were struggling with, right, in your camp.
Oh, yeah.
There were polynomials and equations and things like that, right?
Yes.
So this was a little bit of inequalities. We can do more inequalities, but it depends on what are the other topics that you are facing more difficulties in. So whatever
Oh,
is more urgent, we'll do that first.
yeah.
But try these problems out for the next class. We'll discuss the solutions in the next session.
Okay. Thank you.
Fine. That's all for now then.
Okay, thanks. Bye.
Bye.